For solution stoichiometry, essentially what we're doing is we're combining molarity with our BCA tables. Okay, so I'm going to use this the worksheet that I posted um, as for examples, because pretty much um, just seeing how we work through the problems is essentially going to be your notes for this topic. All right, so let's go ahead and, all right, so it says I have 0.75 molarity of sodium hydroxide, and then I have 275 milliliters of 0.5 molarity. Okay, so the key thing that you want to start doing is anytime you see a volume and a molarity, just automatically have it click, okay, I know moles. If I know a volume, I know molarity, I can find moles. And so that's what we're looking for, because then once we know moles, we can put it into our BCA table. So the question here is it's wanting the volume. So V of the sodium hydroxide. Now, anytime we're doing these acid-base reactions or titrations, the key thing there is both of these are going to go to 0 on there. So let's see. All right, so if I have 0.275 liters of 0.5 molar, I've got 0.1375 moles, okay? And then it's a 1 to 2, so times 2. So my change for the sodium hydroxide oops, wait, I didn't need that minus there. Okay. All right, so I have 0.275 moles, so volume, so molarity, right, is moles over my volume in liters, and so my volume then is going to be moles divided by my molarity. So from the BCA table, I have 0.275 moles. The molarity it gave me was 0.75. So my volume, 0.275 divided by 0.75, 0.37, 0.37, that's in liters, which would be 370 milliliters. Okay, all right, let's look at the second one. Here it says how many grams of lead nitrate. All right, so there, grams, I know I'm going to need a molar mass. So let's find that molar mass. So 207 plus, I got 2 nitrogen and 6. All right, so 331.2. That's my molar mass there. Okay. And so it's wanting grams of the lead nitrate. And it says I have 23.5 milliliters of 0.55 molar sodium chloride. Okay, so again, I got a volume 0.0235 liters times 0.55 molarity will give me my moles, 0.0129. And again, they're only giving us one, so we're going to assume that we're just reacting them exactly for this one. So minus 0.0129, and it's a 2 to 1, so divided by 2, 0.0065. Okay, and it wants grams, so times the molar mass. So 2.14 grams. Okay. All right, so there are a couple of additional problems like these on the first page. So you can use these to practice. The answer key for them is on Otis. All right, but now let's go and look at, let's look at this one here. So here, the key thing is we're given a volume and a molarity of both. So these are limiting reactant problems. So let's look at, so I have 0.05 liters of a 0.5 molarity, and then I have 0.025 liters with 0.033 molarity. Okay, so let's see what we have here. And the question it's wanting is for grams of the precipitate. So let me go ahead before I even start. Let's get that molar mass. So 107.9 plus, so 143.4. It's my molar mass there. Okay. 5 times 0.5. So 0.025 moles of the silver nitrate, and then 0.025 times 0.033. So I get 0.000825. Okay, so for this one, they're 1-to-1. So it's pretty easy to see then that my sodium chloride, that's my limiting. So minus 0.00025, which means this is going to be plus that. $143.4 to get it to grams. And I get 0.118 grams of that precipitate. Okay. All right. So then let's take a look at another limiting reactant. And all right. So for this, I'm going to have to write underneath it because I don't have enough room here. So 50 milliliters of 0.1 molarity and 150 milliliters of 0.25 molarity, and it's wanting the grams. All right, so let's see what that molar mass is going to be. So 3 leads plus 2 phosphates plus 8 oxygens, so 811.5 is my molar mass of that. Okay, so now let's ready to do our BCA. 5. So I have 0.005 here, and I have 0.0375. Okay, so for this one, let's do the easier math is to look at how much of the precipitate could be made. So let's see, so 0.005 moles of the lead nitrate would make, I'll just write precipitate, would make, so it's a 3-to-1, so divide by 3, would make 0.00167 moles of the precipitate, whereas the sodium phosphate 0.0375 moles of that would make, and it's a 2 to 1, so 0.0375 divided by 2 would make 0.01875 moles of the precipitate. So this one makes fewer, so that means that is my limiting reactant. So this is the one that's going to go to 0, right? And then it's going to make, we said 0.00167, and then times 811.5. 1.36 grams of our precipitate. Okay, and the rest of the problems on this page are limiting reactant problems. So you can use those to practice. And again, the answer key is posted in Otis for you.